Hello, let's do the New York Times Medium Sudoku for May 12th, 2024. There's a link in the description if you'd like to try the puzzle yourself using the same Sudoku pad software I do. It's web-based software. And I'm going to get started right now. Okay, so let's go over some terminology first. These are cells. There's 81 of them in the grid, and every cell will end up with a single digit in it. Every cell will have a digit in the final solution. We also have a row. That's a horizontal line of 9 cells, and then we have a column, which is a vertical line of 9 cells. Then we have these 3x3 boxes, which are also 9 cells, and the boxes are denoted by these bold outline regions, these bold outline lines, I should say. So this is a box, but this is not. In addition to that, every row, so in the final solution that we're looking for, every row, every column, and every box will have one of each digit from 1 to 9, exactly one of each. So not 2, not 0. And there is only ever going to be one solution, so we are not going to be guessing. If you start guessing, you're going to start getting it wrong, and you're going to fall into some kind of contradiction. You're going to have to roll back, and it's going to be a mess. So we want to logically solve this. So to introduce how I recommend approaching the solve, learning this specific technique. So we're going to start by going band by band. A band is a row of 3 boxes. And we call a column of 3 boxes a stack, just in case you want to know that too. But we're going to start by going through the 3 bands of the puzzle. I'm going to go top to bottom. This band, then this band, then this band. Okay, what we're going to be doing, first of all, if you think about it, how many of each digit does a band have? It's not really a trick question. It's pretty easy. It'll have 3 of each digit because it's made up of 3 rows. It's made up of 3 boxes. So whichever one you pick, it's going to tell you that there are 3 of each digit, because each row has 1 of each, and each box has 1 of each. So if we find a digit that appears twice in the band, then we've significantly limited where that third one needs to go. And that's what we're going to look for initially. So we're going to start with the box with the fewest givens in it, because what we need to do is compare each box against each other box, looking for duplicate digits. So I'm going to start with this 4 and 8. That way I only have to remember 4, 8, and compare it against these 2 boxes. So 4, we do have a 4 here, and there isn't a 4 in this box. So if you think about the result there, this box is going to need a 4, and this 4 cannot repeat in the row, and the 4 can't repeat in this row. And so it leaves just these 3 cells for 4. And it's always going to be the case that if you find 2 digits in a band, the final digit will be restricted to the 3 cells. Now, those 3 cells can be additionally restricted. For example, this cell has an 8 in it already, so it can't be 4. And we can look down here for 4s. We don't see any, but if we did, that would further restrict it. So we have found that 4 goes in one of these 2 cells. Now we can't place it, right? We can't place just decide on to pick one and place a 4. We don't want to be guessing here, like I said. We want to be logically solving. Every digit we place should be logically proven to be the only digit that can go in that cell. So, but we do want to notate this in some way to remember that we reduced this box. We found that in this box, the 4 was only in 2 cells. And I'm going to use the corner mark mode for that. So Sudoku Pad has 2 different notation modes, corner mark and center mark, which is why I recommend using it. And we're going to use corner mark mode to designate that within this box, the 4 is limited to these 2 cells only. So corner marks will always be box centric. They will be the list of cells that digit can go in. All right, we also have this 8. We do have 2 8s here, but we also have a third 8, so not helpful. We already know where all 3 8s go. Okay, so now that we've compared this box to these 2, we just have to compare these 2 against each other. I'm going to pick this 2, 8, 9. We already know the 8 is in 3 places. And the 2 does not appear in this box, but the 9 does. So we have these 2 9s looking in. And then, so 9 is in one of these 3 cells. We know it doesn't go where the 8 goes. And we also have this 9 down here saying it can't repeat in the column. So there's actually only one cell in this whole box that can be 9. So here it is actually safe to place this 9 because we have proven that cell must be 9. How did we prove it? Well, if it wasn't 9, there would be nowhere to put 9 in the box, and the box the box is supposed to have a 9 in it. All right. So if it needs a 9, that's the only place it can go. So that's the place it does go. All right, cool. So that got us our first digit, and we're confident about that digit. We know that it's true. All right, and so that's all the repeated digits. Now, before we move on to the next band, there's 2 things I want you to look for. You don't always find them, but if you do, they're very fruitful. So the first thing I want you to look for is any box row, so a row that's restrained to a box, any filled box row. So this box row has 2 filled digits, but not all 3, right? We don't have any of those in this band. And we're also going to look for a row or a box that's reduced to 4 or fewer open cells. So this row, for example, is down to 6 open cells. That is not 4 or fewer. So we don't have any of that here either. So I'm going to move on to the next band. And we're going to do the same thing. We start with the 7. There are no 7s here. I'm going to go a little bit faster each band as we go. We do have these duplicate 2s. They look in here. There's a 2 in one of these 3 cells. We'll corner mark that. We also have this 3, but there's no 3. The 6 does duplicate, though, between these 2. And it does the same thing. It puts the 6 down here along with the 2. So we know that 2 out of these 3 cells are going to be a 2 and a 6, which is really important information to know. Can't do anything immediately, but it can come in handy. All right, so that was the duplicates. See how fast that goes? You can do it even faster if you don't blab like I do. And so the last thing we look for is filled box rows. There aren't any. Any rows or boxes down to 4 or fewer? No. Move on to the next band. We do the same thing. So I'm going to start with this 3, 6. We do have 2 3s looking in here. We also have a 3 up here looking down. So 3's in one of these 2. Then we also have these 2 6s looking in, and these 2 are occupied by non-6. And so the 6 must go here. That's a hidden single. Now, when I use the word hidden, that always means that we're talking about a row, column, or box. So in this case, it was a hidden single in a box, right? So that means that within this box, we had only a single cell for a digit, hidden single. So that's what hidden means, because it's not immediately obvious until you inspect that row, column, or box. We'll use the term naked to mean something else later. But I'll explain that when we get there. So we got this 3, 6. We also want to compare this box against this box. We have the 1 duplicated. So these 2 ones look in. That puts a 1 down here. Now, do we have any filled box rows? Yes, we do. We know that this is 1, 4, 6. So we know exactly what digits go in there. So what we want to do is we want to look at the 2 rows in the 2 boxes that this isn't. The 2 rows in the 2 boxes that this isn't, right? So it's these 12 cells. We don't care about empty cells, and we don't care about any digits that are already in the box. So the 3 is the only one we would care about. In this case, the 3 is not helpful because we already have it marked in here. But if we didn't already have it marked in here, notice how we could mark it down here, even without the assistance of this 3, and that's helpful when that happens. But in this case, we don't find anything. Now, any rows or boxes down to 4 or fewer, there are not. So we can move on. Now, what do we do next? You might guess we're going to do the exact same thing, but with stacks. Now, notice how a puzzle can always be rotated 90 degrees. It's the same puzzle, right? So whatever you did the bands, we're going to do the stacks, but we're going to use columns instead of rows. Wherever I said row, just use column instead. Sorry. Beard hair. Yuck. Okay. So let's do this stack. So we'll start with this 7. We do have a 7 here. These look up. Puts a 7 in one of these 2 cells. Oops, I hit the wrong button. There we go. Now we compare these 2 against each other. So I'll look at 1, 4, and 6. We don't care about 7. We already did it. So there's just the 4. Between 1, 4, and 6, there's just the 4. So these 4s look in. We're looking for a 4 over here desperately. We don't see one. And so 4 ends up in one of these 2 cells. If there was a 4 here or here, that would have placed it, which would have been nice. But no luck there. No filled box columns. No columns or boxes down to 4 or fewer. So we can move on to this stack here. I'll just start with this 1, 3, 6 down here. You could really start with any of the boxes. So we do have the 3 and the 6. Let's do them one at a time. These 2 3s look up. These aren't 3. That lets us place this 3. Now, we placed a digit in an area that we had already done a scanning pass on. So we need to do what's called following up, right? We follow up on placing that. We want to look at the additional consequences. And the most important additional consequences to look at, you don't have to limit yourself to this, but I will in this solve. The most important things to look at are when it involves something you've already scanned, and you now have updated information. So we already did this band, but now we need to use this updated 3, right? So it does have a buddy now. This 3 didn't have a buddy last time, but it does now. So we need to follow up on that. And then we also have this 3 down here looking in. So that places the 3 in this box. Now, had we already done this stack, we'd want to follow up on it. I'll say we'll just get to that stack when we get to it. So we don't want to get too ahead of ourselves because we might forget what we're doing and what we're following up on. Now, it did fill this box column, but we haven't gotten to that yet in this stack. So we don't need to worry about that. Did it reduce a row or box down to 4 or fewer? In fact, it did. It's up to you if you want to follow up on this right away. I will. But it's perfectly reasonable to say, well, I'll come back to that because I haven't even finished like some basic scanning in this stack. So I might just find what I would have already found that way. But let's just at least think about what these 4 digits are, and it can be fruitful to do so. So the 4 digits that are remaining for this row that haven't been placed yet are 1, 5, 6, 7. So I'm seeing that this cell can't be 1 or 7, for example. So let's start with this cell here. We want to remember, so what 2 digits, this cell is down to 2 digits only, right? Because I listed 1, 5, 6, 7 for the row, but this cell in particular can't be the 1 or the 7. So this cell can only be 5 or 6. Now it could be either one, but we don't know which. We're going to use center marks to remember that. We can't use corner marks because corner marks are supposed to be the comprehensive list of cells that can be that digit. A center mark we're going to use as a comprehensive list of digits that can go in the cell. So instead of being a list of cells for the digit, it's a list of digits for the cell. And so it's a very cell-centric marking. And so in the solution to the puzzle, if we were to look at the solution, this cell would end up being either a 5 or a 6. You can kind of think of it as a 50% chance, but I mean, really, it's 100% chance to be one of them and 0% chance to be the other, because there is only one solution technically, but we don't know right now. So we don't know if this is going to end up 5 or 6, but it'll be one of them, and it won't be anything else. Okay, so what I recommend doing is if you find a cell is reduced to 3 or fewer candidates, so basically 2 or 3 candidates, you would use center marks. If it's down to 1 candidate, that's called a naked single. You can fill the digit, because if it's down to only one possible digit, that's the digit that goes there. So this cell in particular, it sees a 3. No, 3 is not important. It sees a 6. And so this can only be 1, 5, 7. So we can mark that. This also sees a 6, so it's down to 1, 5, 7. Now this can be any of 1, 5, 6, 7. Now something that I noticed while filling that out is that these were the only 2 cells in the row that could be 6. No, I noted that these 2 6s are conveniently removing 6 from these 2 cells. So none of these cells can be 6. So the row needs a 6. It's going to be over here somewhere. Now something to notice about that is that both of these cells are in the same box. They're in this box. So wherever the 6 ends up, if the 6 ends up here, or if the 6 ends up here, the result is the rest of the box cannot be 6. So the rest of the box doesn't care which one ends up 6. We know that one of them will be 6, and so the rest of the box will not be 6. So that's the logic there, and that's called claiming, because the row is claiming the 6 from the box. It's saying, hey, dibs on the 6. I need it. So the rest of the box says, oh, okay, I won't place the 6 elsewhere. So we can use corner marks to remember that. Even though corner marks are box-centric, we have actually proven that the box will have the 6 up here. And so that is a valid corner mark to do. And it can be very useful because now we know that none of these are 6. Okay, and the corner marks are going to try to remind us of that. Okay, so now we kind of want to rewind a little bit. We were following up on this 3, and we got all of that from following up on the 3. I think that's all we need to follow up on for now on that 3. And so we were scanning this stack, right? So the next thing we wanted to do was the 6. So that does put a 6 in one of these 2 cells. And then the 2 also has a buddy up here. So we were doing this 1, 3, 6. We found the 3 and the 6. The 1 doesn't have a buddy. And then now we're going to compare these against each other. And this is the 2. So the 2s look down, and there's a 2 down here. Now, did I fill a box row? I absolutely did. There's a filled box row. Sorry, box column. There's a filled box column. And so what we want to do is we want to look at the 2 columns in the 2 boxes that this isn't. We don't care about empty cells. We don't care about any digits that are already known in the box. But the 1 and the 6 are special, right? So the 1 and the 6 aren't in the box yet. So look at the consequence. First of all, the 6 actually is already marked, so we don't really care about that one. The 1 is not marked, though. So look at the consequence here. The 1, this one down here says these 3 aren't 1. And these just happen to not be 1. They're filled with non-1s. So there's actually only 3 cells left in this box that can be 1. So we can corner mark that. Now, this does something called pointing. Technically, all of these do pointing, but this is the first productive pointing we've seen. So this is where I'm going to explain it. It's very similar to the claiming that I just talked about, but it's kind of in reverse. So we were looking at this box, and we discovered that within the box, these were the only 3 cells that could be 1. So one of these cells will be 1. And what do they have in common? They're all in the same column. So the rest of the column doesn't care how this 1 resolves for the box. All it knows is that these can't be 1 because the 1's going to be up here. It's called pointing because you can kind of draw a line between the cells. And think about an arrow tip. It's going to point at the rest of in that direction and say, hey, no more 1s. So that means these can't be 1 specifically. And this one looks in as well. So that means 1's in one of these two. So the consequence is very similar to these claiming 6s, which is that these two cells aren't 1 when we thought they could be, but now they can't because we've proven they can't. Okay. So that is what we did with that filled box column. Now we look for any columns or boxes down to 4 or fewer open cells. I am seeing this column is down to 4. We want to think about it. I know that these are going to be worth marking right away because we know they can't be 1, and 1 is one of the digits we need. So we're down to 4 digits, and these can't be 1. So these will be down to 3 by definition, or fewer. But let's think about what are the digits that are actually missing. We need the 1, the 4, 5, and 7. 1, 4, 5, 7. So this cell's not 1 or 4. So this is only 5, 7. This one's not 1 or 7. So this is only 4, 5. This cell's not 5, so it's 1, 4, 7. And this one's not 7, so it's 1, 4, 5. Okay. Those are all worth marking. Any other columns or boxes down to 4 or fewer? I don't see them. So we are going to move on to the last stack here. Notice once we start doing follow-ups, it can take a while to unwind all the way back and finish up a stack. And that's good. That means we're getting a lot of information about the puzzle, and we're getting closer to solving it. So we're going to start with this 3, 6. We do have these two 6s looking up. It does place this 6. Now, the immediate follow-up we can do with that is we see that we have, when we place a digit, the most immediate follow-up you want to do is look at its row, column, and box and see if there were any markings. Like even if you don't have this red marking enabled, the red marking just kind of assists with finding that. But it's just so I don't miss it while I'm solving these walkthroughs. But we want to scan the row and scan the box and scan the column for any pencil marked 6s we had. And we want to say, well, that can't be 6 anymore because we can't repeat the 6 in the row. So if this is not 6, that removes one of our 6 corner marks from this box. So what's the consequence of that? Well, there's only one 6 corner mark remaining. So that's a hidden single. There's only one place in this box for 6. The corner mark has informed us that this cell is 6. All right, so we want to continue to follow up in the band. So we have all our 6s marked, so that's fine. We don't need to follow up on that. Did we fill up a box row? We did not. When we also did this stack, so did we fill up a box column? We did not. Did we create a buddy? Well, we already have all 3 6s. So that's fine. Did we reduce a column or box to 4 or fewer? Or a row in this band or box to 4 or fewer? The answer is yeah, a few of them. So I'm going to start with this row here. This row is down to 1, 2, 5, and 7. This one's not 7, so it's 1, 2, 5. This is any of them. This can't be 2, so this is 1, 5, 7. We have matching 1, 5, 7, so we're always on the lookout for stuff like that. It doesn't do anything yet, but it could do something if we get another 1, 5, 7. And then this 1, 2, 5, 7, this also isn't 2, so it's 1, 5, 7. So did you notice something that happened here? I hope you did. If not, we have claiming again. This 2 says not 2 there, and this 2 said not 2 there. So actually, this row claims the 2 here. So the 2's in one of these 2, which means it's not in the rest of the box. So now, if the 2's in one of these 2, and this 2 is up here, none of these can be 2, which means that the 2 is actually, and this 2 says not here, right? So we can place the 2 in this box is the conclusion. And that means this is down to 1, 5, 7, which could come in handy. This row is down to 4 digits now, 1, 4, 5, and 7. This can't be 1 or 7 or 4. So if it can't be 3 out of the 4 digits, it is that 4th digit. It is the 5. And that places our 6 here. This cleans up the 5 here and the 5 here. Cleans up this corner mark 6. These are just down to 1, 2, 7. So let's do that. It's not a 2. And then this 6 that we placed removes this 6 corner mark. And so we can place the 6 in this box now. The 2 is not placeable, though. There's still 2 places for it. Did placing the 6 do anything? Not that I can tell. No need to follow up on that. Up here, I do want to think about these. These are 1, 4, 7. Let's just fill that out. And I see that this can't be a 1. Okay, we got a lot of information about this band from following up on that place digit. Let's scan this stack again. Let's just go back in time here. 3 and 6. We do have these two 3s now. This 3 looks in. That places this 3. Follow up on it. We have these two 3s. They look in. This 3 looks down. That places a 3 here, and that removes a 2 and a 4 corner mark. So we want to look at both. That lets us place this 2 and lets us place this 4. The 3 also removes this 3 corner mark, letting us place this 3. The 2 removes the 2 corner mark, letting us place this 2, which lets us place the 7. And now the only digit left in the box is a 1. Could have done that in the reverse order as well, if you preferred. Naked single 1, starting with. This is not 1. These aren't 7s. This is not 1. Okay. Let's make sure we follow up on this stack. We just got a bunch of digits in it. So this box is filled. So we basically just want to think about what these boxes need. Let's start with this column, which actually only needs 2 digits. We need the 2 and the 9, which is not resolved. But in this box, it leaves 2 digits. The 5 and the 8. So if you don't understand why these are only 5, 8, it's because the 2, 9 are over here. You can think about it as the 2s and 9s both claiming, if you prefer. Or you can just think about this naked pair here, where this can only be 2, 9, and this can only be 2, 9, and they can't be the same digit as each other. So one of them will be 2 and one of them will be 9, so the rest of the box can't be 2 or 9, because they're going to be here. So these end up being only 5, 8, which is not resolved or anything. But we can look at, let's just look at this box in general. It needs a 1, 1, 5, 8, 9. So I'm seeing that the 9 is placed. It's here. We have these two 9s. And then we're down to 1, 5, 8. I'm just going to fill that out. This can't be a 1. Okay. We could corner mark 1s here, but it's not really necessary with what we've got marked in the box. Okay, so did we follow up on everything here? We've got this 9. We need to follow up on that. Puts a 9 down here. This row is just 1, 4, 5, 8. This can't be a 1, so this is 4, 5, 8. This row is down to 1, 5, 7, 8. Neither of these are 5. So these are 1, 7, 8. That one's not an 8 either. 1, 5, 7, 8. It can be any of those, so we're not going to mark it up. And now this box is down to 1, 4, 7, 8. So notice that the 4 has to be in one of these two cells in the box, so we can mark that. Now that does point. The box has reduced the 4 to these two, so the rest of the row can't be 4. So we can remove this 4 center mark, first of all. We know these aren't 4, and we know this 4 looks in, so we can put 4 in one of these two as well. 1, 4, 7, 8. I'm actually not seeing anything else to do with that here. We don't really want to mark it because it's all 4. All right, so we were still doing this stack. Let's just make sure we finish that up. We were doing this 3, 6. The 3, the 6. Okay, we got that. How about 2, 3, 5, and 9 up here? So the 2 has a buddy. Let's do that. 2 is down here somewhere. We already took care of 3. 5, no buddy up there. 6 we took care of. 9. We do have the 2 9s looking down. So 9's in one of these 3. Okay. Columns or boxes down to 4 or fewer. We already took care of these boxes. I don't think there's anything to do there. Well, this column is down to 1, 2, 7, 9. So this can't be 1 or 7. So this is down to 2, 9. This can't be 1, so this is 2, 7, 9. And I think this can be any of 1, 2, 7, 9. Okay. But marking this 2, 9, we want, whenever you mark especially 2, but anything you center mark, you want to be looking at the row, the column, the box for matching up buddies. And we see that we have this 2, 9 pair here. This is a naked 2, 9 pair. Naked means we're focusing on the digits available in the cells. We're not worrying about like a box or anything. So these are 2 cells that share a row, and they coincidentally both can only be from 2 or 9. Now we know they can't both be 2 and they can't both be 9. So that makes them a naked pair, where one of them will be 2 and one of them will be 9. Now think about which cells don't care which order they resolve in. The result is the same. These cells don't care. Whether this is 2 or 9, making this 2 or 9, these cells still see a 2 and a 9. So they cannot be 2, 9 themselves. So what are the 3 digits that this row still needs other than 2, 9? It needs 4, 5, 8. So we can put 4, 5, 8 in here. And we end up with a 4, 5, 8 triple remaining here as well. Okay, so that 2, 9 pair. The other thing the 2, 9 pair does is it does kind of act as a buddy if we have any other 2, 9s around. But we don't really, so can't really do anything. Okay. What do we want to do next? So did we fill any box columns is a question to ask. But box columns in boxes that we already have full information about aren't important. We don't need to worry about that. So we don't have any useful box columns. And columns down or boxes down to 4 or fewer, we already looked. We took care of that. So we got through all our bands and stacks. We tried to do the follow-ups as best we could. The puzzle's not done. So what do we do now? Well, my recommendation is to go box by box, looking for stuff that's maybe a bit more subtle. Boxes that you already have full information on, I would just double check your corner marks to make sure you're respecting them, like 4s in these two, make sure these don't have 4 in them. 1s in one of these two, make sure these don't have 1 in them. Other than that, there's not much else to look out for unless you happen to spot, oh, I have a pair or a triple or something within the box. That's a good thing to notice as well. You can also look at these center marked cells and just make sure you scan around to see if there's any pairs or triples that maybe you hadn't noticed as well. So there's a lot of things you can be looking out for. If you want, you can try to just keep looking in multiple passes as well. But all of these I'm not interested in. Now, this is the first box that could be interesting, but I don't know if it is yet. So what I'm going to be looking for is when we have digits from both sides looking into the box, restricting that digit in interesting ways. That's the most important thing to be looking for. So often what you can do is you can pick a pair of givens, right? Just pick 2 givens. They're going to, especially if they share a row or column. So in this case, these share a row. There's going to be a column that they don't occupy, and there's going to be 2 rows they don't occupy. We don't care about within the box itself. We want to try to find duplicate digits within those, like between the column and the rows. So for example, but we don't care about duplicate digits that are already in the box. So the 3 would be the only one that could, and we don't care about the 3. So that's not, the 3 is already placed in the box, so that's not fruitful. We also have this 2, 6. They're not sharing a row or column, so there's only going to be a single column and a single row. But if you do find a duplicate that's not already placed in the box, that can still be useful. Now the 1, we already know where it goes, so that's not going to be helpful. So yeah, we can also look at this, we can look at these, and we can look at these and see if we find any duplicates there as well. You start to get an instinct for which duplicates you want to look for. So obviously the 2, 6, and 3 are already placed in the box. The 5 doesn't have a duplicate, 8, 9 doesn't, right? So you can scan that pretty quickly once you get used to it. So we're going to move on to the next box. I didn't find anything useful in this box. We're going to look at this box. This box we already checked. It was 1, 4, 7, 8 left here. There's nothing restricting that. So I don't think we're going to find anything beyond these pointing 4s that we already found. So we can move on to this box. This box we have full info. How about this box? So, excuse me. So in this box, we might look for something in this column looking in that could be useful. So the 2, 8, or 9. So we'd look for a 2, 8, 9 around here. We don't see it, unfortunately. So we can't use that. We could try to use the 3, 6 or the 1, 6. There'd have to be something interesting in this row. So the 4 would be the only thing that can be interesting. We look up here to see if there's any 4s that could help, and there's not. So that's not going to be helpful either. So yeah, I don't think there's anything in this box. But finally, we have this box here. We're double checking our corner marks, make sure we respected them. We're also looking at this 3, 6. Unfortunately, there's nothing in this row that helps. So unfortunately, we didn't find anything in that pass, but if we did find something, it would have been quite useful to get us progress on the puzzle. So this puzzle is hanging on. So the next thing that I want to look for is what I call restricted cells. So cells that are down to 3 or fewer. But we haven't marked every cell that way, right? So there might be cells that are hiding that are still 3 or fewer that we haven't found yet. We want to center mark them and try to find pairs or triples or something like that. The easiest place to look is if there are any remaining rows, columns, or boxes down to 4 or fewer open cells. I would start looking at those. We can double check the ones that we already looked at, like this 1578. Can this still be 1578? It actually can't be a 1 because we have the 1's corner marked here, the 1's corner marked here. So this is down to 578, so we can mark that. We know that this can't be 1 anymore, so since 1 was removed from it, from kind of in a non-trivial way, I just want to think about what it can be still. So it can't be 1, 2, 3. I'm going to write it out, but I might erase it. It needs a 4. It can't be 5, 6. And it needs all of 7, 8, 9, which is a problem. So that's 4. We don't really want to mark that. But I think it was worth checking. Okay, so I don't know that I'm going to find anything there. We know these are 1, 4, 7, 8. Okay, how about in this box? So these two cells aren't the 2, which may be useful to know. So let's think about what's needed for these cells. Well, in general, the box, I'm actually going to focus on this one here. This row isn't helping, right? This row doesn't help, but this row could. This row is contributing the 4 and the 6. So this cell, I guess the 6 already couldn't be. It's contributing the 4. It's contributing something. Anyway, let's look at it. It's not the 1, 2, 3, or 4. It could be 5. It's not 6, but it could be all of 7, 8, 9. So we're not worried about that either. Okay. In this box here, we have this cell, which isn't filled, and we know it's not the 1, 2, or 9 from our corner marks. So that could be helpful as well. So what can it be? It can't be 1, 2, 3. It can't be 4. It could be 5. Can't be 6. Could be 7, 8. Can't be 9. So it is worth leaving as a 5, 7, 8. Things I'm looking for are 5, 7, 8s around it. I'm seeing this 5, 7. We could form a triple with that if there was another 5, 7, 8, but we know there's not over here, so that's not actually helpful. All right, so what am I actually missing? I am a little bit puzzled. Okay, so if you don't think there's any cells remaining that are worth marking up, I am going to double check just... It can be worth looking at cell when you have 5 or fewer if you think there's particularly good restrictions on the cell. So, I mean, this can't be 5, but I think just thinking about what this column needs can be helpful. It doesn't take that long to enumerate it. And when it's 5, it's not that hard to remember. So 5 is about my limit, but we need 1, 4, 5, 7, 8. So I'm looking for cells that see a lot of 1, 4, 5, 7, 8. And I'm just not seeing them here. Like these two, like this one can't be 5, so it's 1, 4, 7, 8. Right? We already knew that for the box. This one, 1, 4, 5, 7, 8, it's not really seeing any of that at all. So that's not helpful either. So if we're not finding any helpful cells to mark up, the sort of next thing to be looking for is to go box by box again, but instead of looking internally into the box, look at the box's effect externally. And we want to focus on areas that we haven't kind of completed yet. Like we've basically completed a lot of these boxes, even or like really marked them up well. Oh, okay. So I am just examining this box. I am seeing something that I hadn't noticed before, which is we did limit the 7 in this box to these 2 cells, and that is going to point down. So this can't be 7. In fact, none of these cells can be 7 anymore. So that does mean in this box, 7 is in these 2 cells. It means this can't be 7. I'm not sure that did much else. This is down to 1, 8. Could that be helpful in some way? Not that I can tell. This can't be 5. The column still needs a 5. 1, 2, 3, 4, 5. Yeah, let's think about what this column needs. It needs 1, 4. Now, when I said 4, something I noticed is that none of these were marked with a 4, so I immediately became suspicious. But 4 is down to these 2 cells. We can't actually do anything with that yet. But it's 1, 4, 5. The thing I noticed is this was the only one that could be 5. We know this can't be, but this can also be 5, so not helpful. But okay, so we're going to keep going. 1, 4, 5. This is why we list it out in our head, so we can pay attention to what that means. So 1, 4, 5, 7, and 8. So we know that none of these are 7s. We don't even have to worry about 7. It's 1, 4, 5, 8. So this can't be the 5. So this is 1, 4, 8. So Now that it can't be 7, it is worth marking as 148. This can't be 7, so it's 1458, but I think it could be any of those. So that's not helpful, unfortunately. Okay, so let's go back to scanning boxes. Just looking at a box again can sometimes just be very helpful. Even just rescanning to see if you missed something in your initial scans, like just looking at buddy givens again, that can be helpful as well. But basically what I'm going to be doing is I'm going to be going through each box. So like this box does affect some of these cells here that we don't know everything about yet. So I'm skipping this top band basically, but I'm going to look at this I'm going to look at the place digits in this box, and I'm just going to focus on them, right? I'm going to think about each one at a time. So I'm going to think about 2, right? We kind of know about 2s here. We do know about 2s here. So we're not worried about that. Now I'm going to think about 3. I'm just going to go in numerical order. I think about 3. 3s are done here. 3s are done here. Not worried about that. I think about 4. Okay, 4 is done vertically. How about horizontally? Is there anything special about 4s? Well, yes, these are 4s that we've got corner marked already. So if we didn't remember that yet, well, we could say, hey, well, actually, these aren't 4, so maybe there's something special about these now that they can't be 4. So let's just think about what they can be, right? They can be 1, but only this one of the 2. They can't be 2 or 3 or 4. They can't be 5 or 6. And so then 7, 8, 9 are what's left there. So actually, this is worth marking because it's only 7, 8, 9. This one is 1, 7, 8, 9, so we're not going to bother marking that. We're going to actually delete that now. I don't think the 7, 8, 9 did anything immediately. I'm thinking about 4 in this column. We already have a lot of places for it, so that's not useful. So, but just going around thinking about each digit can make you realize things that you didn't realize just because you're focused on it. So the 6s are done in the whole puzzle, actually, so we're not worried about that. 7s, we have 7s marked here. What about 7s in this box? Is there anything special about 7s in this box? We're also thinking about 7s in rows and columns, but there's nothing to do there. Okay, now we look at the 9. We do have the 9s marked here. Vertically, we know the 9s are here and here. We're just trying to think about how 9s are affected. So yeah, not much to do there, but that's okay. We thought about it. Now let's going to think about these 3 digits, the 2, 3, and 6. Start with the 2. We do have these 2s marked. We have these 2s around here. No, we're not going to find much there. The 3s are done in the puzzle. 6s are done in the puzzle. So we're not worried about 3s and 6s at all. How about this 2? So we do have these 2 buddy 2s. The 2 ended up down here. How about horizontally? We have these 2s, all 3 of them. Okay. How about the 5? Okay. 5 is something we want to think about because we don't know much about 5s yet. So maybe there's something interesting. Something I'm noticing is 5 is in one of these 2 cells in this row, for example. That might come in handy at some point. Not handy yet. So thinking about 5s, I looked up and I said, well, maybe there's a 5 up here that I didn't notice. And actually there is. There's pointing 5s from this box. So 5 is in one of these 2 cells in this box. And that does point down, removing 5 from here. And remember I said 5 had to be in one of these 2? Well, actually, by thinking about that, I noticed some pointing that I hadn't noticed before of these 2 5s. And so now that does place the 5 in the row. And that's going to be huge because that resolves this entire box. This can only be 8 now, and this can only be 1. It also resolves this 5, 8 pair here. Placing the 1 resolves the 1 in this box. Also huge. Because the 1 then is resolved. And it's actually up here. It's not resolved. But now this is down to 4, 7, 8, so we can mark it. We also know this can't be 8 because we placed this 8 in this 5. So we want to think about what that 8 and 5 placement did. Make sure we don't miss anything with that. So this 5 looking down, this 5 looking in, that's something we were looking for before, but we didn't have. Now we do. So this 6, 3, right? We find this 5, we find this 5. 5 is limited to these 2 cells in this box, and that is going to point up, making this a 1, 7, and 5. Very nice. That's going to resolve this whole box. It's also going to resolve this 4, 5 pair. It resolves the 8 here as well. Resolves this whole column. This 4, 5 pair resolved. The 4 in this box is resolved. We get the 1, 7, and 8. This whole box resolved. Yeah, I think that was it. I think we're finishing the puzzle. This 7 and 9 is remaining for the box. This 7 tells us the order. That's 9, that's 7. Over here, well, this can't be 7 or 8 anymore, so it's only 5. We end up with this 2, 9 pair here. So the 2, 9 can't actually go down here. In fact, this is the 1. These 2 can't be 1. And so we need a 7 and 8. And this 8 tells us the order. That's 7, that's 8. All right. Now we just think about what the 4 digits in this box are, and we'll finish. So we need a 2, 3, we need a 4. So 4 ends up exactly here. That places our 2, resolving all of the 2 9s around here. We need an 8 and a 9. They go like that, and we're done. So what we had missed were when we center marked here and when we center marked here, we missed pointing. We missed the 7s pointing here. We missed the 5s pointing there. It's very easy to miss. And so that's why if we get stuck, we're going to go through, we're going to go box by box, and we're going to think about them carefully. And if we do a pass on it and we still didn't figure it out, we're going to think about them more carefully. We're going to go through again. We're going to re-look for stuff we already found. We're going to double check that there aren't restrictions we didn't notice. We're going to look at restrictions in rows and columns by focusing on individual digits. That's what eventually made me find these corner marked 5s, because I missed it twice around. Because I thought, oh, we already know what we need to know about these boxes, but we didn't. We didn't know about the pointings. But once I focused on this 5, I did notice that only these 2 could be 5 in the row, and that prompted me to look at the columns to say, are there actually any restrictions on 5 that could help me? And I found it. So if you get stuck on a puzzle, those are the kinds of things to look for. It can take some time, but it's often what you're missing. So. Hope this was helpful as kind of an unintentional instructional aid on what to do when you get stuck. And of course, if you enjoyed this, then why not leave a like, subscribe, and a kind comment below.